So binomial distributions come up so often that they have their own fancy name. They have all this fancy terminology, and lucky for us, there's some fancy shortcuts in our calculators as well. Binomial, we've actually talked about some of those before. Like when a family of 4 has kids, each one could be a boy or a girl. There's 2 possibilities, right? And then we know the probability of each. The probability is 1/2 for a girl, 1/2 for a boy. When you play the lottery, either you win or you lose, and the probability of winning is the same every time. So those are binomial. Bi means 2. When there's 2 possible outcomes, that's a binomial situation. So we're going to start off with a list here, and then we're going to talk about them as we go through the examples. Binomial distributions have to have a fixed number of trials, meaning you know how many items you're looking at. In my family of 4, I was looking at 4 kids, so that was fixed. I wasn't going to, I say, wow, is 4 an unusually large number of girls? You would need to know it's 4 out of 4, not 4 out of 100 or something. So you need to know how many is your total. That's the total. That's the number of trials. Think of that as your n, your sample size. 4 kids, you have a little n next to there. The trials are independent. Oh, what does that mean? There's a review statement.
Separate events.
Separate, that was disjoint. Independent, you're kind of close though.
The trials are independent.
Independent.
Does that mean it doesn't like the?
They don't affect each other. Is that what you were saying too?
Yeah.
So for example, when a person has a baby girl, and then they're about to have another kid, does the fact that they had a girl the first time affect what happens the next time? Definitely not. So those would be independent events. Or if I'm flipping a coin and I got tails and I got tails, I got 4 tails in a row. Does that affect how likely it's going to be tails the next time? No, because those are independent. Dependent, remember, were things like if your alarm clock doesn't go off, that affects whether or not you get to class on time. Those were dependent. When you took things without replacement, you changed your fractions, the denominators changed each time. Those were dependent because what happens the second time, depending on what happened the first time. But if they're independent, each time it's the same, then that's what we're talking about. There must always be 2 outcomes. We call it success and failure, but it could be heads and tails, boys and girls, win or lose. We'll determine what a success is based on whatever the question might be. And then the probability of a success is the same in all trials. That actually comes from the independent part. Every time I flip a coin, there's a 1/2 chance that it's tails. Every time. It doesn't ever change, it's something different later on. Every time you play this particular lottery in California, there's a 1 in 575757 chance that you pick the right combination. So that probability is the same every time you play. Everyone okay? Remember the probabilities are always the same? If all of those are true, then it's a binomial situation. So my first example is I'm going to flip a coin 10 times, and I'm going to count the number of times that it comes up tails. So let's go through my categories. Are there a fixed number of trials? Yeah, 10 times. I'm flipping it 10 times. So my n is 10 in that case. 10 trials. Are the trials independent? The first flip, does it affect the second flip? No, they don't affect each other, so they're independent. Right? Are there 2 outcomes? Yeah, heads or tails, my only possible outcomes. And is the probability of a success, in this case a tails, the same every time? Yeah, so that would be a binomial situation. So right now we're just deciding is it binomial or not. And then what we do with it we're going to do in a minute here. Okay. A through C are not binomial. Let's see if we can figure out why not. So question A, so you have 152 couples. Again, they're trying this gender selection method that comes all throughout this book. And then they're recording the age of the parents. Why is this not binomial?
There's more than 2 possible.
Aha, there's more than 2 possible outcomes. How many possible outcomes are there? Well, what are they? They're not asking the gender. What are they asking?
Age to be in this.
The age. So one parent says, hey, I'm 25. The other one says, I'm 32. This guy says, I'm 49. There's way more than 2 possible outcomes there. There's so many different ages. If it had said they were asking the gender, Kirsty, we would have been okay. But they didn't say that. They said they're asking for ages, which is why it's not binomial. There's more than 2 possible ages. How about B? Do we need to write that down or we got it?
Got it.
Got it? Didn't write it down.
Got it.
So because there's more than 2 H's. So the next one says now they're going to treat couples with the Y-sort gender selection method, and they're going to record the genders of each of the babies that are born.
There's no fixed number.
Mm-hmm. Kevin says there's no fixed number.
Couple.
How many couples am I talking about? 4 couples? 8 couples? 1,000,000 couples? We don't know. If you don't know, imagine if I said, hey, I found 4 people that all saw this particular movie. Only 4. Well, 4 out of how many did you ask, Jill? If it's 4 out of 4, that's everybody. Right? But if it's 4 out of 1,000,000, that's hardly anybody. So it kind of depends on the question, right? So you have to have the fixed number of trials. There's no fixed number of trials in this one. Okay, there. How about C? 200 staff students, randomly selected, asked whether or not they own a TI-84 Plus calculator. What's the problem here?
Probably the success is the same in all trials.
Yeah, the probability of a success is not the same. Everyone's going to say yes or no, and we know how many people, but we don't all have the same probability of owning a calculator. Some of us, maybe you're lucky enough that, Kanye West is my best friend. And he bought me 700 calculators. Blink of an eye. And I shared them with all my
Yeah, a
friends.
friend gave me this.
You got one from him too?
A friend gave me this one.
A friend gave you that one.
Yeah.
Or somebody else, maybe you're on financial aid, you're helping support your family, and you had to scrape together pennies. Maybe you had to borrow one from our lab because you couldn't even afford one. Different people have different probabilities, so in that case it wouldn't be a binomial, because we have different probabilities for each person. Kanye didn't really buy me my calculator. Just so you know. I never met him. Okay, so now there's a whole bunch of notation at the bottom, which isn't so bad as long as you can follow along what it is. P is the probability of a success. So my example of flipping a coin, what was P? Probability of a tails? What's probability of getting tails?
50%.
50%, but we do as a probability, it would be 1/2 or 0.5, right? Q is the probability of a failure, which would be, in this case, still 1/2. The tens or its tails. But it could be like this is my P, and this is my Q. This is the probability of winning, this is the probability of losing. This could be a P and a Q. They don't have to be the same. Everyone all right with what I mean by that's P and that's Q? If the success in this case is winning this Fantasy 5 lottery. So P and Q are the probability of winning, the probability of losing. They are complements of each other. We see that? They must be complements. It even says 1 minus P.
Yeah.
Tells you they're complements. N is the number of trials. I mentioned that up above. So if I wanted to play this lottery over and over and over again, because I still am convinced I'm going to win, if I play it 47 times, that'd be my N. Or if I flip my coin 10 times, that's my N we talked about. And then P of X is the same thing it's meant before. It means the probability of getting exactly that number of successes. We had that in the first example, which I've done erased, with the girls, and we had X and P of X. And for 2, it was 3/8, I think, or something like that. I don't remember what it was.
Possible outcome.
It's the probability for that many outcomes. So we're going to actually talk about specifics with that. So when they say, P of 2, going back to that girl question from earlier today, they're saying, what's the probability of getting exactly 2 girls in that family? That's what that means. P of X just means find the probability of that number. And then, look at that beautiful formula. P of X, that's a scary looking formula. Does the first part of it look familiar?
Yeah.
What's it look like? It has factorials in it. It's like the combinations and permutations that we did last time, right? And we decided we were never using those formulas again because they were too messy and we were going to use our calculator for those. So we could use the formula for binomials, but more importantly is that we recognize it's binomial and our calculator is going to find binomial probabilities for us. using what's called Binomial PDF. I'm at the almost bottom of the page there. Binomial PDF. And then next to it I have NP and X. Here's the really good news about those. They're in alphabetical order. So if you forget which one goes where, hopefully you know your alphabet. If you know what N is, what P is, and what the X is, you can always find a probability. We're going to go through some examples. I'm going to add another one right next to it here in a few minutes here. There's also a table in the back of the book. If you ask the computer to help you, it'll say either use this or use this table. The table's very cumbersome. We're not going to use the table. We're just going to use our calculators. Where you find it is a little bit different. It's somewhere new. Somewhere new for us. It's under distributions, which is right underneath the arrow keys. Right underneath the arrow keys.
Next to clear.
Next to the clear. I couldn't hear you say, Kevin.
Above the bars?
Yeah, above the bars. So you see where it's in blue or yellow, depending on your calculator? Can someone turn one of the light switches? Because she's not there. Someone else reach the light switch? Just one of them? Thank you. Let me clear it. Is it up there? You guys see it yet? So here's the VARS button right here. Right above it, mine is in blue. Some calculators are yellow. It says DISTR, D-I-S-T-R. You see it? And if it's in blue and it's or yellow and it's up above here, you have to hit second first and then distribution. So you should get this screen first. Everybody get this far?
Yeah.
These are all the distributions. We're going to keep going down until we find binomial PDF. It's down there somewhere. Ah, not too far. I have like a delayed reaction. I went too far. Hang on. I'm fighting with my calculator.
It's 0.
Yep, it's 0. I'm trying to get back up to it. Oh no, it's A on mine.
It's A on mine.
Binomial PDF
Binomial PDF, then a half parentheses.
with a half parentheses. Everyone find this line? If I hit enter right here, again, my screen and your screen are going to be different. Some of us have trials P and X value. Trials P and X value. Other people, I know Kevin has the other calculator. You probably just get this word binomial PDF. Where you have to put N, comma, P, comma, X.
Okay.
So I put them in 3 lines. You're going to put them all in the same line. We don't have a question yet, though, to put in there. I just want to make sure we know where to find it.
values in there, right?
What'd you say?
You put the values.
We're going to put numbers in there in a second, yes. Did everyone get to this part at least?